Now, if you have transition metals, they can have ligands attached to them. Now, these ligands will attach in an odd ratio. Consider copper to hydroxide. Copper has a +2 charge within this solid, yet 4 ammonias will attach to it. We'll see that we'll often get twice as many ligands attaching to transition metals as the charge of that transition metal. And those ligands will attach to that copper. It's almost like they've formed a covalent bond with it. And so we don't break those ligands off from those transition metals when we're writing net ionic equations. And so we could say here that we've essentially got 4 ammonias now stuck to copper. And we released those 2 hydroxides. In this net ionic equation, we're showing that by adding ammonia to this transition metal precipitate, that precipitate is dissolving. It was all solid, but now it's all aqueous. We can dramatically increase the solubility of transition metal precipitates by the addition of ligands. By the way, transition metals are transition metals are Lewis acids. They accept pairs of electrons, whereas Lewis bases, ligands, they can donate pairs of electrons. So as an example, ammonia has the following Lewis dot structure. We can see that it has a lone pair of electrons, which could be donated to these copper ions as so. Okay, so we see, yes, twice as many ligands will attach to the transition metal as its charge, and we dramatically increase the solubility of these compounds. So some examples, common examples of transition metals that can form coordination complexes, complex ions, are silver, copper, cadmium, cobalt, iron, nickel. And additionally, for the ligands, common ligands include ammonia, cyanide, hydroxide, and chloride. And just as another example of the formation of a complex ion, we have ammonia being added to a suspension of silver 1 chloride. Now, by suspension, we mean that that is not a homogeneous solution, but instead there are small particulates of solid silver 1 chloride dispersed throughout it, which would eventually fall to the bottom of that mixture. And so we have solid silver chloride, which we're adding ammonia to. Now, silver has a charge of +1, and so it will have 2 ammonias attached to it, twice its charge, and so we'll get 2 ammonias attached to it and form this complex ion, and this will release chloride, dissolving that solid. What would we observe if we were to have this reaction occur? We would take solid and it would dissolve. All of these other compounds are aqueous here. So you dramatically increase the solubility of this compound. Now you might be concerned or wondering about the charge here. Why isn't there a charge on this silver with the 2 ammonias attached to it? Well, we combined the silver +1 with 2 ammonias, and those ammonias have no charge. And so they don't affect the charge. The complex ion still has a +1 charge. Yet there are other cases where we could add chlorides. For example, if you were to take copper 2, that would attach to 4 chlorides actually to form copper with those 4 chlorides attached. But what would be the charge? Well, you combine a +2 with 4 -1s. That would actually be 2-. So you'll have to be calculating for the new charges. Thanks for watching, guys.